Hey, welcome back, everybody. Today we are starting a new topic, and this new topic is the first of two topics that will focus on algebra. And so this is what your parents consider algebra or would think of algebra. It's going to be using a lot of variables, and we'll be doing things like evaluating and solving different types of problems. Today we're focusing in on how to write and evaluate algebraic expressions. So we know what the word write means. To evaluate means you find the value of, so notice how value is the root word. Algebraic means we use variables, and expressions, we're going to learn about what expressions are. So today your agenda is that students will be able to write and evaluate algebraic expressions, and I want you to think about how algebraic expressions can be used to represent and solve problems. Before you watch the video, you were to complete the Venn diagram, and now we're going to correct your work. So you were to take each capital letter and place it inside the Venn diagram. So uses a variable. So all three of these use a variable. I just noticed down here it should say inequality. So let's take a moment to write inequality. So not equal. So letter A says uses variables. All three of these can use variables, so the letter A goes here. As an equal sign, only equations have equal signs, so the B goes here. Is an unfinished idea, that's an expression. Uses numbers. Expressions, inequalities, and equations can all use numbers. Says two expressions are equal, that's an equation. That's how equal and equation have the same root word. Solved. Inequalities and equations can be solved. Expressions cannot be solved. Does not have an equal sign. Expressions and inequalities do not have equal signs. Can be evaluated. So expressions can be evaluated, and that's what we'll be focusing on during this topic. It's a completed idea. Equations and inequalities are completed ideas, so the I goes here. And two expressions are not equal is an inequality. Let's turn the page over. Actually, before you turn the page over, turn back to the Venn diagram. So during this topic, we're going to focus only on expressions. So we're going to be focusing in on how to write expressions and how to evaluate expressions. Expressions use variables and numbers, but they do not include an equal sign. They are considered incomplete thoughts, kind of like a phrase in English. So you know how a phrase is not a full sentence? An expression is not a full equation. It's not a full inequality. During this topic, we'll learn only about expressions, and then during the next topic, we'll learn about inequalities and equations. Expressions have many different parts, so you can turn the page back over, and we're going to learn about the different parts of an expression. So it says an expression is a mathematical phrase that contains numbers, variables, or both. An expression does not have an equal sign. Expressions can have different parts. Let's look at an example. This is an example of an expression, 8n minus 3. The n is a variable, which is a letter that represents an unknown. A coefficient, this is a word from last year, a coefficient is a number that's multiplied by the variable. So in this case, 8 is a coefficient. Constant is a number without a variable. So the number 3 is a constant. And then terms are parts of the expression that are separated by plus or minus signs. So in this problem, or in this expression, we have two terms. One term has a variable, the other term is a constant. So if we look at these examples, we have 7g minus 5 plus 3h. How many terms does the expression have? Well, the expression has 1, 2, 3 terms. What are the variables? The variables are g and h. And the coefficient of the third term is positive 3. And the next we have negative 7a minus 5b plus 8. How many terms does the expression have? The expression has 1, 2, 3. Notice how I circle the subtraction symbol in front of it, because that's really like adding a negative. So I circle the subtraction sign in front of it. What's the constant term? The constant term is 8. And what is the coefficient of the first term? That's negative 7. You're going to complete the next two. You can either do that now by hitting the pause button and then unpausing, or you can do that when the video is over. In the next group here, you're going to complete these first on your own, and then you're going to compare with a partner. I'm going to do one for you. It says you're going to write an expression with two terms. The second term should be a constant. So that means that the first term should have a variable. Second term should be a constant, like that. So with the next one, it says the expression with, it should be an expression with three terms. The first should have a negative coefficient. The second should have n as a variable and a coefficient of 8. So three terms. This one should have a negative coefficient. The second term should have n as a variable and a constant of 8. A coefficient of 8. Doesn't say that we need a constant, but I just used a constant because we need to have three terms. But this one has the first term with a negative coefficient, a second term with n as the variable, and a coefficient of 8. It doesn't say anything about what to do for the third term, so I just chose to use a constant. So again, do this independently and then compare with your partner after. The last page I want to do with you is the page that says writing algebraic expressions. So to translate a verbal expression into an algebraic expression, first look for keywords that tell you whether the expression involves addition, subtraction, multiplication, or division. I added some words to the table, so please write these words in. So I wrote perimeter, and then they had plus, sum, total, increased by, and more than for addition phrase. So add perimeter to that list. We have minus, difference, subtracted from, decreased by, and less than. Multiplication, we have times, multiplied by, product of. Words like twice, the word each, area, the word of, the word by. Like when we talk about dimensions and we say that something is 10 feet by 12 feet, that means multiplication. And for division phrases, we have quotient, divided by. When we talk about splitting something or splitting something equally, that's a division situation. So here are some examples and their solutions beneath them. So Here's 7 increased by n. Here's 10 less than h. 3 times the total of 6 and x. This one can be tricky. So it's 3 times, and then the word total means addition. So it means that 6 and x are being added together, and we're doing 3 times that. So the first one says the sum of q and 8. So sum means addition. Next, the quotient of 9 and c. So quotient means division. So we could either write 9 divided by c, or you could write c, either way. 7 times m. You'll see us write it without a dot when we have variables, so we write 7 times m like that. You can also write it with a dot if you wanted to and write 7 times m. Twice the sum of j and 4. So that's just like this. So twice means 2 times. The sum is another word for total of j and 4. So it's going to look like this. So twice means times 2. The sum of j and 4. You're going to go and finish these problems here, and then have one of us work so far before you flip the page and keep working. Okay? So have someone check this page and the page before you go on to the next page. All right, started.